look at inscribed shapes, there's a lot of different varieties on here. You might see a triangle, you might see a quadrilateral. But in this video, I'm going to concentrate on inscribed triangles, and in particular, inscribed triangles where there's a diameter as one of the sides. I can see that's a diameter because the center of the circle is on that segment. And that's going to be really important because the diameter cuts the circle in half, which will put 180 degrees of the circle on this side and 180 degrees of the circle on the other side. That's going to be a key feature. So I'm going to go ahead and write 180 degrees for this. And then I'm going to go like that since I don't have a lot of colors, and call that 180 degrees because the circle is 360. Well, the importance of this is, if this is 180 degrees for the arc, if you come back into that angle, then that means that angle needs to be 90 degrees. And that's going to be true anytime you have a diameter and then the inscribed angle. 180 divided by 2 will get you to 90. Now we can look at the question that says find the radius. Well, it's a right triangle now. Good old Pythagorean theorem will get us the diameter, and we'll go from there. 3 squared is 9. 4 squared is 16. That gives you 25 when you add them together. When you do the square root, you get 5. So the diameter has a length of 5. What we need to get from the diameter to the radius, we can cut that in half. So our final answer would be 2.5. Here's another one of the same fashion. It wants us to find the measure of angle F, that's down here in the triangle, but let's just fill in some other details, and those details might help you on a different problem. All right, the diameter cuts off, this arc is 180 on this side. These arcs over here would add to equal 180. Well, that gives me this that I had on the last one. This is a diameter, this is a right angle. Now we focus on the triangle. We know every triangle's angles add to equal 180. We already have 90 and we have 70. Okay, 90 and 70 is 60. That leaves 20 degrees down here for the final angle. So our final answer is 20, but as I indicated, we're going to do some more questions just for the sake of helping you on other problems. This is an inscribed angle, so if this is 20, it would double to give us this arc of 40. That's why the 90 doubles to 180. And if this is 70, this arc right here, 70 doubles to 140. And notice this checks with the 40 and the 140 cutting off the half of the circle 180. A little messy, but lots of details there to share with you. This final one, we've got the diameter again. We're going to find the measure of arc BC. Well, the key fact is the one we used on each of these problems. If this is the diameter, then this entire arc is half the circle, which is 180 degrees. Meanwhile, they tell us this piece of the arc is 104. So what we need to do is 180 minus 104 to get that leftover portion, which in this case is 76 degrees.